Okay, let's evaluate a composition of functions. These are trigonometric functions. You'll notice we have a cosine on the outer as the outer function, and then tangent inverse as the inner function. So when we get going on these, it's important to note we don't have the exact same trig function, so it's not cosine, cosine inverse. We're not going to get any nice canceling out here. Whenever we have the inverse function on the inside, though, like we do on this one with tangent inverse, what I always like to do is just get started here by drawing myself. Well, I'm going to do a let statement. I'm going to go ahead and let theta, some angle, equal whatever the inner function is. So tangent inverse of 5/12. So what that allows us to do is we're allowed to rewrite our original expression here. We can rewrite this as this is equal to the cosine of, we can replace everything on the inside here. The tangent inverse of 5/12 we said was just equal to theta. All right. Next up, what we want to do is rewrite our equation we just created where theta equals tangent inverse of 5/12. Let's rewrite that in terms of tangent without the inverse. So this can be thought of as tangent of theta by applying a tangent to both sides is going to equal 5/12. Basically, as you apply the tangent on the right-hand side, the tangent composed with tangent inverse is going to do some nice canceling out for us. So we know that tangent of theta is 5/12. Let's draw a quick right triangle and try to solve this down a little bit. So I'm going to place theta in the bottom left. Nothing's drawn to scale by any means, but from sohcahtoa, what we know is tangent of some angle can be thought of as opposite over adjacent. So in labeling our sides of this triangle, we can say the opposite side is going to be 5 and the adjacent side is going to be 12. Based on this exact same theta, our goal is we want to find cosine of theta. So from sohcahtoa again, we know that cosine is going to be adjacent over hypotenuse. Well, we know the adjacent side is already going to be 12. So I can fill that part in. We have a little bit of work yet to do to find the hypotenuse. So I'm going to call the hypotenuse in this case C. And to find C, I'm using the Pythagorean theorem that says a squared plus b squared equals c squared. And which one of these you label the a and the b really doesn't matter. But this is going to get us to 25 as we square the 5 plus 144 as we square 12 equals c squared. So 169, 25 plus 144 is 169 is going to be c squared. To get c, we can apply a square root to both sides. The square root of 169 works out pretty nicely to be 13. So our hypotenuse in this case is 13. Up here where we're trying to find adjacent over hypotenuse, we can input 13 where our hypotenuse is, and we've evaluated it. Our final solution is going to be 12/13. All right, so as you get going on these, as you have an inverse function on the inside, make a let statement, let theta equal whatever's on the inside, draw the triangle, Pythagorean theorem to help you solve this down and get all the side lengths, and then know your sohcahtoa. You got this. They're not that bad. Good luck.